Our next speaker is from India. His name is Sunny Kabrawala. He's the founder and director at STAR. He will speak on space for everyone, bring space to the classrooms. Sunny, the floor is yours. Go ahead.
So much for the opportunity. We listen to the amazing talks by all the speakers, and whether it be space mining, whether it be acquiring data from space or building rockets, we know it's very clear that for all of these things we need to have young talent. And like at Star, we have firmly believed that the next generation of engineers, scientists, space entrepreneurs are sitting inside the classroom right now. And the way we nurture them is the way they are gonna nurture our world. So today, like I'm representing that 1.2 billion population on the planet, which is very young, which lies between the age group of 14 years to 25 years, and of course 1.4 billion people in India, where every other kid aspire to be a space pioneer. So the question is, like, if you go to the classroom, if you ask students what do you want to become, the most common answer we get is we want to be an astronaut. And the question was very simple, that where are these astronauts going? Why not everyone is able to fulfill that dream of becoming space pioneers? And that's pondering upon these questions, because I was one of them who aspired to be a space pioneer, but just because of my poor academic performance, I could not be in the space industry as a space scientist or the engineer. So I figured out three existing problems in the industry that right now the industry is just for the limited people. And when we talk about them, mainly it consists of people who are from the engineering background or science background or physics background, and people who have deep pockets. So there were three problems. First is we do not have any quick and affordable access to space. And when I say affordable, I mean extremely affordable. That means even students could see a vision of sending an experiment or any object to space as a school and a college or university project. So we have no quick and affordable access to space, and then there is a huge gap between industry and academia. Any technology that has failed reaching to the classroom has failed creating the impact. And still we see that in developing nations, we see there is a huge gap between industry and academia. There is no channel through which we are using the talent which is there sitting inside the classroom and get some crazy ideas from them and implement them to leverage the power of space. And then we have lack of ecosystem for space enthusiasts. I've seen that in American industry, where they have astrophotographers, they have people who are into arts, and they have an ecosystem where people from every background are very well welcomed. And I think we need to create that type of ecosystem in every country. Now the question is that, so this problem is an ever-growing problem. How do we solve them? So there are three key challenges for making space accessible and extremely affordable for people. The first is tech development. Of course, the space tech is a complicated tech, and it takes a lot of factors and a lot of parameters to go everything aligned as per plan, and then whether and still there's a risk whether it would work perfectly or not. So tech development itself is a very complex thing. There's a lot of innovation happening in the industry, but if we talk about, still there are a lot of technologies. There are still technologies and not commodities. If we talk about rockets, we have rockets which are very advanced, using different ways of manufacturing, or we have the advanced engines, but the existing technology is still within the labs and have not become commodities. The second, as I said, commercialization and scalability. I'll take the example of the rocket. They have a very narrow application of putting things into orbit when we talk about the orbital class vehicles, and as I said, limited applications where right now the industry is striving towards scaling up the number of applications which are possible for the launch vehicles or the rockets we have in the industry. Now, what are the solutions for that? And one solution that we see is the existing technology which have not been commercialized so far, which is sounding rockets. So just to be clear here, sounding rockets are the rockets which can go to space and they do not deploy anything into orbit. You go to space and you come back down again. So there are a lot of benefits of them. In orbital class vehicles, the missions are super expensive. But in sounding rockets, the missions are not expensive because you are not putting anything into orbit. Second thing, you're not even buying the communication bandwidth, because you can store your data and you can get your payload back. The sounding rocket can actually open window of space for students and who aspire to send experiments to space. I think companies, if they start focusing on making sounding rockets more and more economical, the chances of bringing space to the classroom would scale up. The second is space wearables. Creating an environment among young people. This movie industry is doing it amazing way that like Marvel have got their own merchandise which is out there, and kids they like to wear them, and they feel like superhero. Why not to have space wearables where every individual they feel connected to space? Okay, and then space education, because as I said, to scale up any industry, we need to get into the classrooms where students are sitting, and these students are the future of our planet. And if we can inculcate that, not just the knowledge, but that inspiration amongst them, where they can, not only build great technologies, but also inspire the next generation to do the same. So I think these are the three ways where we can actually get these space to the classrooms. Now, for that, we at STAR have designed a core technology called, which is a sounding rocket named Kalam. It's a tribute to Dr. APJ Abdul Kalam, sir. And there are three core tech differentiator about this design. The first is, the simplicity. We have done nothing new with the rocket design. We have kept the design very simple, easy to manufacture, zero novelty, zero innovation, but the existing technology which can be commercialized. And it is super affordable. And the way we were able to do it is we used no CAD software. We didn't use any simulation platforms for designing and simulating the performance of the rocket. In fact, what we did is we just dealt with basic mathematical equations, and we performed the simulations in the Excel sheets, and that's how we could actually get the data is verified. And then the sustainability, the 100% of the design is reusable. So we're not deploying anything into space, creating no junk there. And as I said, you can get the complete rocket down on Earth and launch them for more than 5 to 6 times. And that's how the cost of the rocket gets divided by, not just hundreds, but thousands and thousands of customers. And when I say customers, I mean students who aspire to launch something to space. Now, just few quote texting about the rocket. First, it have a custom payload interface. So it's not just for the students, but if any private startup or the government agency want to test their space systems, they can actually put that on the payload structure, and they can launch it to space for microgravity experiments. I think Alexandra mentioned about in-space manufacturing, and she talked about semiconductor industry. This rocket is one of the most perfect designs for testing the semiconductor manufacturing methods and even drug development methods for pharmaceutical companies. We have composite structure, which is lighter in mass and which have a better strength, and it's going to be the first Indian-made hybrid rocket engine to space. So we are using nitrous oxide, which is laughing gas, which actually made us cry for almost 1 year while designing the engine. But yeah, the hybrid rocket engine, using nitrous oxide as the oxidizer, and we have paraffin wax, which is fuel, and these are very safe propellant fuels to deal with. And who all needs space? That's the question, right? Because you build something and you don't have customers, it's very difficult. So, as I said, schools and universities are the primary targets, the student clubs and teams, and all the research organizations. And also, we're trying to launch products of startups to space. It's like a space marketing, which is a very new genre which is coming up. Space education, I think every nation should have this in their education policy now, where short-term courses like master classes should be introduced, which inculcate the interest among the students. If we do not show them what they're capable of and what they can do with space, I think the space is just going to be limited to few engineers and scientists on the planet. And the future is going to be really boring if we don't see students launching things to space. And if we really want to make humans interplanetary species, then we need to involve young minds into innovation and building technology. And the last is training, where once the students who are interested in building their career in space, I think we should give them hands-on experience on building technologies and provide them 24/7 lab access where they can actually build space products and innovations. Now, final thing, which is a human, he connected humans to technology, and we know him as Steve Jobs. who built the best products in the world. Then came a human who built technology which connected, technologies with space, and we know him as Elon Musk. Now it's time for us to connect humans to space. And as I always say, that it just takes passion, purpose, perseverance, and a black jersey to change the world. Thank you so much.
Thank you. Thanks so much, Sami.